Hello everyone and welcome back. I am Mr. Cobalt and today I'm going to be going over molecular ionic and net ionic equations. So I'm going to start with this example here. So what you see here is you have lead 2 nitrate aqueous put together or reacting with potassium chloride aqueous, and it forms lead 2 chloride solid. So here's a precipitate, and it has also potassium nitrate aqueous. And so this is an example of a molecular equation. So I'm going to write molecular equation. So molecular equation. And the reason this is called a molecular equation is because everything, all the ionic compounds are written together as if they are molecules. When in fact, in reality, because I've said this before, aqueous means dissolved in water. So when an ionic substance is dissolved in water, these ions are not together. They are actually separated, floating around in the water. So they are not together. But when we write them together as if they are molecules, we call that the molecular equation. So we write this together in formulas. And this one here is the only one that is actually together because it's a solid. So these two ions are together. And these ions are not because they are aqueous. So this is an example of a molecular equation where everything is together and it's balanced, right? So it's a balanced molecular equation. Now, what about the ionic equation? So the ionic, or also referred to as the complete ionic, right? So sometimes it's referred to as the complete ionic equation. That is where you separate all of the ions for the aqueous solution. So you're writing it more closely to the way it is in actuality, in the beaker. So for example, this is aqueous. So in reality, these ions are floating around. They are not together. So what we're going to do for our complete ionic equation is we're going to separate the ions. So I'm going to write the lead, and that's a 2 plus, so I'm going to write 2 plus, and then this is going to be aqueous, right? So I separated that ion, and then I'm going to write plus, and then here I have 2 nitrate ions. So that the subscript here is going to become a coefficient. So I have 2, and I'm going to write the 2, I'm going to write nitrate, and there's a negative charge, and aqueous. So I've just separated the ions for this formula into separate ions. So now I have, for every one of these, I have 2 of these, just like the formula says. And they're both aqueous. And I do the same thing for this one as well. So, and the coefficient here is applied to both ions. So I have 2 potassium, so I'm going to write 2 potassium, and it's a plus, and that's aqueous. And then the chloride ion as well, plus 2 chloride ions, and that is aqueous as well. So I've just separated both of the reactants into their separate ions, and now I got to do the products. So here's my arrow to the products. And I get to my lead 2 chloride. So lead 2 chloride is a solid. So those are together. So I'm not going to separate those into its ions. I'm only separating the aqueous solutions into the ions. So here, I'm just going to write PbCl2 solid. So that's going to stay the same. I'm not going to separate that. And then finally I have my potassium nitrate, and that's aqueous. So I'm going to separate those. So I don't have room here, so I'm going to just write them down here. So again, the coefficient applies to both ions. So it's going to be 2 potassium plus, and that's aqueous, and then plus 2 nitrate ions, negative, and that's aqueous as well. And so this is our complete ionic equation or ionic equation. So complete ionic equation. And as you can tell, the reason it's called a complete ionic equation is that all of the ions are separated except for the solid substance here. So if it's aqueous, then you separate the ions and everything is balanced as before. So if I had a subscript for the polyatomic ion, I have it as a coefficient. If I have a coefficient, then that coefficient is going to apply to both ions when I separate them. So that's how you write your complete ionic equation. Now, what about the net ionic equation? So let's think about what net means, right? So if you think about your paycheck, so if you're working, you have your gross pay and you have your net pay. And your gross pay is the payment or your income before taxes are taken out. So without taxes being taken out, you have a gross income. But your net income is after you've taken out the taxes. So whatever's left over is your net pay. And it's the same thing with the net ionic equation. So what you have to do is you have to look for the ions that are not doing anything in solution. So those are going to be considered your spectator ions. So as we know, spectators are those people that are in the stands, usually at a sporting event or some sort of event, and they're not the ones that are participating in the event. They're just spectating, they're watching. So they're not doing anything, they're not playing the sport, they're not doing anything in the play or whatever it is that you're spectating. So the spectator ions are the ones that are not involved in the reaction. So you can find the spectator ions really quickly by looking at the product. So if you form a product, here we have our solid. So the only 2 ions that are involved is your lead-2 ion and your chloride ion. And so those are the ions that are the players, and the rest are going to be the spectators. And another way you can tell by the spectators is the fact that they don't change their state from before and after the reaction. So if they stay aqueous, that means that they haven't changed, they are not doing anything. So lead has gone from aqueous to solid, being part of a solid, so that's a change, right? So lead is participating in the reaction. Nitrate, you have 2 nitrates that are aqueous, and you still have 2 nitrates that are aqueous. So it's not doing anything before and after, it's not involved. So that is a spectator ion. So this is a spectator ion. And here we have the potassium ion. So we have 2 potassium aqueous, and we have 2 potassium aqueous. Those are the same, they're not doing anything. It's the same before and after. So this is a spectator ion as well. And here you can see the 2 chloride ions end up in the solid. And so these are players. And so when you figure out who the players are, you eliminate them from the reaction. So we're going to cancel out the spectator ions. And then the players are the ones that are left. And if you write those down, that will be your net ionic equation. So you have Pb2 plus aqueous plus, and then you have 2 chloride ions, aqueous, and those come together to form your solid, PbCl2 solid. And so this would be your net ionic equation. So it's the same as the complete ionic equation, but you've removed the spectator ions that are not doing anything. So this is your net ionic equation. And that's it. And so I hope this is helpful in seeing the differences between your molecular, which has everything written together as if they're molecules, aqueous, aqueous, solid, and aqueous. Your complete ionic equation is separating all of the ions that are in aqueous, making sure that you are balancing and keeping the same number. And remember, the coefficient applies to both ions. And if you have a subscript for your polyatomic ion, then you need to make sure that's a coefficient. And then you find out what your spectator ions, eliminate those, and only include the players. So lead, 2 chloride, and then you get the solid. So I hope this was helpful, and if you like this video, please like it, share it, subscribe to the channel. Make a comment in the comment section. Let me know what you think. And ring the bell so that you can get notifications for any new videos I put out. Thanks for joining me, and see you next time.